third example of utilizing the variation of parameters method to solve a non-homogeneous differential, y double prime minus 2y prime plus y equals e to the x over 1 plus x squared. Clearly, this would be very difficult to use the undetermined coefficients method because of the right-hand side. So just like we've done a number of times, we're going to start by finding the complementary solution. Looks like we're going to have a double root here. This factors into m minus 1 squared. And so m1 equals m2 equals 1. And so our complementary solution is going to be c1 e to the x, c2x e to the x. Okay, remember this is a case 2 because of the double root. And then also we can identify y1 to be e to the x. We can identify, unfortunately, y2 to be x e to the x. And I say unfortunately because that means when we take the derivative, there's going to be a product rule. And then our function, which we really don't like too much, e to the x over 1 plus x squared. Hopefully no integration by parts, but if there is, hopefully it's nicer than it was last time where we had to do a u substitution and integration by parts. Alright, let's start finding w. Remember w is y1, y prime 1, y2, y prime 2 in the determinant. y1 is e to the x, derivative of e to the x as basic as it gets. y2 x e to the x, using our product rule of derivatives, e to the x plus x e to the x. Alright, and fortunately for us, w is going to work out okay. So we're going to cross down, we're going to cross up. When we cross down, we get e to the 2x plus x e to the 2x. Then we're going to subtract out an x e to the 2x. And fortunately for us, we're just left with e to the 2x. Alright, so that's nice. w1 is going to be equal to 0 f of x, and then y2, y prime 2. Alright, and again, let me verify. I keep forgetting these. I apologize. Yep, 0 f of x, y2, y prime 2. Getting better. Alright, so that's going to be equal to, if you cross down, 0. And if we cross up, remember f of x is that e to the x 1 plus x squared. Alright, and y2 was x e to the x. So that's going to be 0 minus x e to the 2x divided by 1 plus x squared. Or negative x e to the 2x over 1 plus x squared. And then finally we need w2, which shouldn't be too big of a deal. So w2, remember our formula for w2, y1, y prime 1, 0 f of x, doesn't even matter what this is. Remember y1 was e to the x, and we know f of x is e to the x over 1 plus x squared. And so we end up with e to the 2x over 1 plus x squared minus 0. Alright, so now we can find u prime 1 and u prime 2. Remember, u prime 1 is w1 over w. w1, remember, was that opposite of x e to the 2x divided by 1 plus x squared. And we found w, I believe, to be x e to the 2x. Let's go back up. Or it's just e to the 2x, excuse me. And that's good, because we're going to be left with negative x over 1 plus x squared. Certainly tolerable when we go to integrate it. Right? U prime 2 is going to be w2 over w. w2, I believe we got e to the 2x, 1 plus x squared. Yep, right here. So that's e to the 2x over 1 plus x squared divided by w, which was e to the 2x. And even more tolerable is u prime 2 is 1 plus x squared. Now we're going to integrate each of those, and then we'll throw everything back into our particular solution. So now remember, to get yp, remember that's equal to y1 integral u prime 1 dx plus y2 integral u prime 2 dx. And so we just need to integrate the two functions above. All right, so up here, we're just going to integrate. I'm going to pull the negative outside, x over 1 plus x squared dx. And over here, if we bring this one down, integral of 1 over 1 plus x squared dx. All right, so we're just going to integrate those. The good news is the second one is just a basic antiderivative, so no tricks on this one. This, remember, is just our arctangent. All right, so that's good. So we're going to hold on to that. Over here, it's a u sub. We're going to let u be equal to the denominator, 1 plus x squared. Du equals 2x dx, which is really close to what we want because we have an x dx. We just want to get rid of the 2, so we're going to divide both sides by 2. And so this now becomes opposite integral of du over 2 over u, which is going to be the natural log of u times negative 1/2. So I'm going to pull that 1/2 from the du over 2 out. We're left with ln absolute u. Remember, u was 1 plus x squared, so we get minus 1/2 natural log of 1 plus x squared. Right. And so now we can plug everything back into yp, right, and then we can get the entire solution. So y sub p is going to be equal to, remember, y1 all the way back was c1 e to the x. We just want the e to the x. So e to the x times this negative 1/2. So I'll just say times negative 1/2 of ln of 1 plus x squared. And then we had an x e to the x for y2, and we're going to multiply that by the arctangent of x. All right, and so finally, for our y of x, after all of that mess, that's going to be equal to c1 e to the x, c2 x e to the x, minus 1/2 e to the x, ln absolute 1 plus x squared, and then finally plus x e to the x arctan of x. All right, and so that should be sufficient for us. Again, very difficult to do, if not impossible, by using our undetermined coefficients method. All right, so we have one last example. We'll see that in our last video, and then we'll be done learning about our variation of parameters method.